Hi there, welcome back to another Instagram request video. This time I'm going to be sort of doing a basic introduction to permutations and combinations. Now, these are used normally to arrange items or to choose items. So say we have a certain number of items, we might want to see how many ways we can arrange those, or we might want to choose a certain number of items from our given set of items. So hopefully that makes sense. Right, when we're talking about permutations, the order in which the items are arranged matters. So for example, if we were arranging the letters ABC, right, ABC is a completely different permutation to BAC. Okay, these are completely different. Right, and in fact, what else have we got? We've got CBA and so on. They're all different permutations. So all of these are different permutations. In fact, there's 6 of them, and we'll get onto that in just a moment. In a combination, however, the order doesn't matter. So in this case, ABC is the same as all the others, BAC and whatnot, CBA. And that's basically, if you understand these two, you should have no problem understanding the rest. Okay, so let's start with a little example of a permutation, and this will actually allow us to derive the formula for permutation. So let's say, I don't know, how many ways are there of arranging 5 objects? Right, and if we imagine this is our first place, this is second, this is third, this is fourth, and this is fifth, well, we have 5 objects, so in the first spot we have 5 ways which we can arrange. In the second spot we're going to have 4 ways because we used one of them. In the third spot we're going to have 3 ways, and so on. Right, and if we multiply all of these together, this will give us the number of ways to arrange these 5 objects, which is of course 5 factorial, and this is 120. So there's 120 different ways of arranging 5 objects. Note here the order matters. Okay, great. Let's say we wanted to see how many possible 3-man teams there are if we start with 5 people. Okay, so how many 3-man teams from 5 people? This time the order doesn't matter. Right, so for example, say if our 5 people were Alice, Bob, I don't know, Eve, John, and Mark, and say one of the ways we chose the team was Alice, Bob, and Eve, this is the same team as, well, let's just turn them the other way around, Eve, Bob, and Alice. Okay, so we've got to be a little bit careful. So this time, number of teams, right? Well, in our first position, we're going to have 5 choices. In our second position, we're going to have 4. And in our third position, we're going to have 3. But what we need to do is divide by 3 factorial. Because there's 6 different ways of arranging these. As there are 6 arrangements for each team. So the number of teams is 5 times 4 times 3 over 3 times 2 times 1. So it's 5 times 4 times 3 over 3 times 2 times 1. These are going to cancel, and we're going to be left with 10. So 10 teams. So this is an example of a combination. Okay, so this is our problem. How many teams of 3 can be selected from 5 people where we have a captain, vice captain, and a spokesperson? So this time, the order does matter, okay? And hopefully you can see why. So if we say captain, vice captain, and spokesperson, and we've got Alice, Bob, and Eve again, this is a different team to having Eve as captain, Alice as vice captain, and Bob as spokesperson. So different teams. Okay, great. So This time, all we've got to do to work out how many teams, so number of teams, well again we've got 5 choices for the first slot, 4 for the second, and 3 for the third, which equals 60 teams. Okay, so let's generalize this. So we have 2 formulas. We have one which is NPR, right, and this is so permutations of R objects from a total of n, right? And the formula is like this. So NPR equals, so it's n factorial divided by n minus r factorial. Right, and you can see in the case above, I'll write it here. So we were choosing 3 people from a group of 5, and what we did was we did 5 times 4 times 3. But we can see this is the same as 5 times 4 times 3 times 2 times 1 divided by 2 times 1. Right, because these are going to cancel and we're left with the same thing. And then this is 5 factorial over 5 minus 3 factorial, which is 2 factorial. So this is the formula for permutations. So when we're choosing R objects from n items. Okay, finally, if you remember when we had the example where the order of the teams didn't matter, the only thing we did differently was divide by 3 factorial. So we had 5 times 4 times 3 as before, but we divided by 3 factorial. And let's have a look at this as a formula. We could write it as this. It's 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1, right? But we need a 2 times 1 on the bottom as well to cancel off with these, like so. So in our formula, this would be 5 factorial divided by 5 minus 3 factorial and 3 factorial. Okay, which means our general formula for combinations is n factorial over n minus r factorial times r factorial. Okay, so these are now our 2 formulas. This is for combinations, and this one is for permutations. When you see these questions, this would normally be arrangements, and this would be selections. Okay, I hope all of this makes sense. I know it's only an introductory video into the subject, and it can be quite complicated, but the main premise of permutations and combinations is, if you're able to count really well, you'll be absolutely fine. Okay, thanks very much for watching. Any feedback is appreciated. Bye bye.